Back in 2017, I was experimenting with a passcode system in Tumult Hype. It's not meant to secure sensitive data. It's more like an 8-bit Nintendo passcode. Do you remember Punch-Out? The code to fight Mike Tyson is well known. 007-373-5963. That's even seen on t-shirts. This is the logic of the system. If someone cracks the code, it's not a problem. It's actually an advantage. They could tell their friends about the game and the code. Those codes could end up on video game websites, similar to how I made all of those Crossy Road videos. So even though the value in the original passcode template was obscured with Base64, any decent JavaScript programmer could see right through that. This template is not about security, it's about nostalgia. To better illustrate how this works, and to make this technique even more useful in Tumult Hype, I created a minigame. Quick, what's the password? See, you don't know it. Now you could view the source code to find out, or you could just play the game. Click the hero to move to the next scene. The blocky look is reminiscent of those old Atari 2600 games. Fun. This is the first level. The password is Grassy. The previous scene is essentially the title screen, and this is level 1. Video games tend to have common environments, and that first easy level is usually green and grassy. While not super impressive visually, all of the artwork and animation was created in Hype. Let's see what else is in this little game. This is level 2. It's the woodsy area. That's the password. Do you like that tree? It's easily duplicated with the symbol in Hype. Let's keep going. This is level 3. It's the snowy area. This is basically a simple outline of a video game. If the hero travels one more time, the game goes back to the beginning. So now we know all of the passwords. Let's try entering a password. Capital S, letter N, O, W. Do you see the emoji changing? And now the final letter, Y. Boom! The third scene is loading. Isn't that nice? So, how does it work? Well, if you look at the Hype project, you can see all of the scenes. Do you notice something interesting about the scene names? They're the same names as the passwords. That's how this is managed. By using Hype's JavaScript API, those scene names can be compared with the password used. So let's take a closer look at the JavaScript. First, some variables are declared. Text is the value of the text input. Hype 4 doesn't have an element for text input, but one can be manually added with HTML code. I gave it an ID of input. You can see the shorthand for that element here. The IE variable is used whenever working with the input element. The EE variable is the nickname for the emoji element. Here's the important part. It's where the Hype's JavaScript API is used. The names of the scenes are stored in an array. Just a side note, the value of scenes could be from a different set of values, so you don't have to use Hype scene names. Now the action starts. On the input element, an event listener is added. Whenever the input changes, run the typing function. That's conveniently located 2 lines away, and one of those lines is blank. The first part is to add a delay. The password could be checked instantly, but this is to add a little animation. If a key was pressed, the checking won't occur until 1.5 seconds has passed. There's no enter key or a button to press. The field only needs to have the correct value, although the field only accepts letters. I'm using regex to remove anything except basic letters. If a number or special character is added, it is automatically removed from the input field. And while there's typing, the emoji is surprised. Once the typing has stopped, the compare function can run. 2 variables are declared. The letter S is short for the index number of the scene, while the match is currently false. A loop is used to check the scene list. The loop starts with a value of 1, as JavaScript arrays start at 0. And we don't want the first scene. That's the title screen, with an index value of 0. So, one by one, each value is checked for a match. If it finds one, the match variable is set to true, while the S variable is set to the current index number. After finding a match, the loop is ended by setting the I variable to the length of the scene's array. Another side note, you don't have to use a loop. There are easier ways to search an array, such as with the find or index of methods. If you want to challenge yourself, try rewriting this part with one of those methods. Anyway, once the loop is finished, was a match found? If so, then that scene can be loaded. The emoji is changed to show success. Meanwhile, the input field is cleared. It no longer has a value, and the placeholder text is set to correct. It's also set to read-only, to prohibit future typing. Although with the event listener removed, the JavaScript wouldn't run anyway. Also, if you get confused, remember the power of your developer tools. You can leave little messages for yourself to see what's going on. The next scene is loaded with Hype's JavaScript API. If there wasn't a match, the emoji is set back to thinking. Additionally, a console message notes the incorrect attempt, and the typed variable is set to false, as there wasn't typing recently. So that's how the Hype template works. Remember, this is just a starting point. Once again, we can easily see why this is not secure. If you view the source code, you can see the word grassy. Once you know one password, you can easily find the others. Yet there are other applications where that doesn't matter. What if you're using Hype to make a presentation? This technique could be modified to create a dynamic navigation menu. With a drop-down list, you could skip to any scene in the project easily. If this was a college-level class in Hype, that would be a great homework assignment. Anyway, hopefully that information helps. And if you want to learn more about Hype, you might like a book about Hype. It covers lots of useful projects like this one, helping you to make the internet a better place. Thanks for watching.